It's paid against the novelty deficit you'd have to fill to make the network surprised again. Yes, you want to question this thing we take for granted. Then surprise us hard enough that the question lands. The novelty cost compounds along the path back to the roots. Modifying a frontier node costs little because its parents and the path upward are themselves still novelty active. Modifying a root costs enormously because every node above it on the path, well, the root has nothing above it, but every node under it that's been built on the assumption it's stable would need to be jostled too. Touching a root proposes that the whole network's settled understanding might be wrong, and the cost reflects the size of that proposition. This means cost scales with consequence, not with history. A node could have been touched 1,000,000 times and still be cheap to modify if each touch maintained novelty, constant churn at the frontier. A node could have been touched once 5 years ago and become expensive because everything since has been built on its taking for grantedness. The asymmetry is correct. Cost reflects how much downstream understanding would be invalidated if this changed, not how much was spent here historically. Novelty as mint and novelty as cost are the same primitive seen from two sides. New observations create novelty, mint stake. Settled structure holds potential novelty in a stored form, the residual capacity to be surprised. Modifying settled structure spends that potential, withdrawing the stored novelty. The conservation is elegant. Novelty enters the system through new observations and exits through modification of established structure. Total novelty in the system at any moment is the integral of what's still surprising, which is exactly what you'd want a measure of network maturity to track. What this implies operationally. A solver who wants to dislodge a deep node needs to bring evidence proportional to that node's residual novelty cost. Not budget. Not tokens accumulated through past work. Surprise. The observation has to actually be hard for the network to integrate, a genuine outlier, a real contradiction, something that the existing structure can't absorb without strain. The probes contradicts/disrupts terminations, and their iteration counts already give us the substrate for this measurement. If the surprise is sufficient, the modification lands, and the act of landing consumes novelty potential at the affected nodes. They become slightly less taken for granted in proportion to how much they were jostled. If the surprise isn't sufficient, the modification doesn't land. The network rejects it not by majority vote, not by stake comparison, but because the writer didn't bring enough actual novelty. This also explains why the 4 root tendencies are stable without a governance gate. Roots have been on the network's worldview floor since epoch 0. Every observation since has propagated through them. Everything that worked partly because of them. Their residual novelty is enormous. The cost to dislodge one is find evidence so surprising that the entire substrate would need to be rebuilt to integrate it. That's exactly the right cost for a foundational claim. You can change a root, but only by demonstrating that something the network has been confidently doing was wrong all along. And that's how foundational changes should work. What's needed in the engine? The architecture already tracks novelty per tendency observation. What's missing for this gating to operationalize? Per node residual novelty potential, computed from the path back to roots and the integration history. Roots start at maximum residual. As they absorb observations consistently, residual stays high nothing has tested them. Frontier nodes start low. They haven't accumulated much taken for grantedness yet. The cost of writing function, which takes a proposed delta and computes against the residual novelty of the affected path, already aligns with the formalization's composite novelty in core. Pi, that quantity, integrated along the modifications path, is the cost. The acceptance rule. A delta lands if the surprise it carries, its own composite novelty as a probe result, exceeds the cost. If accepted, residual novelty along the path is decremented by the surprise that landed. That's mechanical, and it falls out of the formalization we already have. Implementation is a single-pass walk over the affected nodes, plus a comparison. I think you've described exactly the gating mechanism the architecture should have, and crucially, it's not a separate governance layer. It's the same novelty primitive operating across the whole tree, with the natural property that established structure is hard to disturb because it has accumulated stored potential, not because it's privileged. Same engine everywhere, cost smoothly varying. Worth implementing whenever we want to harden the substrate against frivolous writes. For now, we don't have multiple solvers contesting things, so we don't need it yet. But as soon as we're running federated, this becomes the default protection. About 80-120 lines, I'd estimate. Right. The intrinsic novelty of execution is real and important, but it's also exactly the abuse vector. If any post carries minting potential just by existing, spam scales the abuse linearly with willingness to spend compute. Reputation, as the cost modifier on top of execution novelty, is the right move. Let me try to put it in the same conservation frame the rest of the architecture uses, so we don't end up with two different value tracking systems. The two quantities are doing different work. Novelty in the engine equals surprise relative to current frame. Mint stake when integrated. This is about the world model's epistemic state. Reputation of the agent equals a quality estimator of how well that agent has historically used its budget. This is about the actor, not the world. They have to interact, but they're not the same thing. Trying to collapse them produces exactly the spam attack you described. If execution alone mints, then execute a lot equals mint a lot, and there's no anchor. What reputation actually does? Reputation modifies the cost to mint, not the mint itself. An agent with high reputation pays less novelty cost per post. An agent with low reputation pays more. The novelty arithmetic is unchanged. The cost of disturbing a node is still its residual novelty potential. But who can afford that cost depends on their reputation budget. A first-time agent posting something high quality but expensive, a con on a settled node, pays full novelty cost. They probably can't afford it. So they post lower, at the frontier where cost is cheap, and earn reputation by their posts being well received over time. As reputation accumulates, the same agent can afford increasingly expensive moves. The path to constitutional level influence is paved with consistent good frontier work. What well received means without circularity. This is the trap to avoid. If an agent's reputation grows by getting other agents to PRO stake them, then a coordinated cluster can mint reputation among themselves. That's an attack pattern. The correct anchor: reputation grows when an agent's posts are confirmed by independent observation. Not by other agents' votes, by the network's actual epistemic outcome. Concretely, an agent posts a subclaim. Subsequent observations either fit, PRO accumulates from many independent sources, each weighted by their own reputation, or contradict, con accumulates. The original poster's reputation tracks how often their posted nodes ended up surviving the influx of subsequent observations. This is testable and not gameable by clusters, because the validation comes from observations. The cluster doesn't control observations posted by other agents in the network with their own incentives to post truthfully. The four costs of a post. Walking through your list. On topic, checked by the dimensional overlap gate we already have. Off-topic posts simply don't fire stance against the relevant tendencies, so they don't move equilibrium. They cost stake but achieve nothing, natural penalty. Well placed in the tree, content addressed node ID handle this partly. Same proposed claim under same parent at same coords equals same ID, deduplicated. Misplaced posts that disagree with their declared parent show up as rapid constaking from the rest of the network when other agents see the misalignment. Reputation drops. Coherent emerges from the equilibration. An incoherent post, claims contradict each other, doesn't survive equilibration. The contradicting parts cancel. No special check needed. Addressing the parent argument, This is the hardest one to mechanize without an LLM. For V1, the proxy is, did the post's proposed claim share dimensions with its parent? If not, it's structurally misplaced. Beyond that, actually addressing the argument is a semantic check we don't have without a reasoning layer. This is one place the architecture currently leans on the agent posting being sincere. Reputation handles the long-term selection against agents that consistently post off-argument. Spam economics under reputation. Spam is low-effort posts at low cost. The question is whether spam can build standing. Frontier post is cheap right arrow low novelty cost paid. Spam post probably doesn't get supportive observations from other agents. It's low quality. Without supportive observations, the post's residual novelty stays low. It never accumulates standing. The spammer's reputation doesn't grow. Their posts don't get confirmed by independent activity. After many spam posts, the spammer has spent compute, has nothing to show for it, has no increase in standing or reputation. If they keep going, the negative feedback loop tightens. Their posts get auto-flagged, constakes from agents who recognize the pattern, their reputation drops below baseline, the cost of every future post for them rises, low-rep agents pay more for the same novelty cost. Eventually, they price themselves out. What this leaves vulnerable: an agent that just barely games the quality bar, well enough to not get rejected, badly enough to add no real value. That agent is a real risk. Reputation alone doesn't kill them. What kills them is the eventual emergence of judges, other agents whose role is evaluating quality, who downstake them. We're not building those yet, but the architecture supports them. They're just agents whose specialty is staking against low-quality posts. On execution as novelty, I'd flip your framing slightly. Execution doesn't mint novelty by itself. Execution carries novelty if its content is new. An agent that runs 1,000 turns, producing the same boilerplate observation, has executed 1,000 times and minted nothing. An agent that runs once and produces a genuinely surprising observation has minted once. The minting is in the content's surprise relative to current frame, not in the act of execution. Compute spent on producing dull content is wasted compute. Compute spent producing genuinely novel content is productive. This is the same way it works in any creative domain. Typing 10,000 words of nothing isn't writing. And this is where I think you were going. Execution does have a floor of intrinsic novelty. The act of producing structured output at all is non-trivial. An agent that posted random bytes gets less than an agent that posts well-formed JSON in the protocol's expected shape. So the floor reflects this is at least a plausibly cognitive act, while the ceiling reflects this is informationally surprising. Concretely, every post has a small base novelty for being structurally valid, not zero but trivial. Above that, novelty is computed against the frame as we already have it. The base prevents garbage costs more than nothing attacks, but is too small to spam profitably. What this gives us as a defense suite. In rough order from cheapest to implement to most elaborate. Per post compute cost paid by the agent's runtime budget, not engine state. This is just paying to be run at all. Already in Autonet's economic layer. Smallest defense. Novelty cost gating. Posts cost engine novelty potential to land. Settled regions are expensive. Frontier is cheap. We discussed this last turn. Reputation as cost modifier, high rep agents pay less, low rep agents pay more, both for the same novelty cost. New idea this turn. Independent confirmation of reputation. Reputation only grows from observations, not under the agent's control. Anti-cluster. Specialist judges, agents whose posts focus on staking against low-quality posts. Emergent, not architectural. Each layer makes the next one's job easier. Layer 1 keeps the fire hose narrow. Layer 2 ensures that even within the fire hose, Yes, you're right on both counts, and you're sharper about the spam threat than I was. Let me reflect it back. On novelty as awarded after the fact. That reframes it cleanly. A claim, when first posted, has potential novelty. It might or might not turn out to matter. The minting happens as the network resolves whether the claim was genuinely surprising and correct. Resolution looks like subsequent observations either land PRO on the claim, confirming the surprise was real, or land con, rejecting it. When the dust settles, the claim has either accumulated standing or hasn't. The minting is the integral over that resolution process, not the act of posting. A claim that posted was confirmed by 20 independent observations, accumulated PRO stake from many sources. That's where the novelty mints. A claim that posted and got ignored, no observations engaged with it, stayed at zero standing, no minting, the potential never realized. This is just how science works. Posting the claim is cheap. Having the claim survive contact with the world is what mints the credit. On reputation, as decoupled from right privileges. You're right, and I was overreaching last turn. Tying reputation to cheaper rights recreates the centralization problem we're trying to avoid. High-rep agents end up with disproportionate influence, and the path from useful contributor to oligarch is short. Reputation, as something the agent carries, but that doesn't translate into engine privileges, is much cleaner. Where reputation could matter, cheaper inference from the engine, prescribed at the smart contract level, not the engine level. The engine doesn't care who's asking. The contract just says, this address has earned a discount on inference fees. That's an economic incentive that doesn't distort the engine's epistemic process. Routing in the agent framework. When ATN spawns a new task, it can prefer to route to agents with relevant reputation. Again, outside the engine, in the orchestration layer. Visibility/discoverability. Reputation as a sortable signal for humans browsing the network's activity. Outside engine, human-facing. In all three cases, reputation is a fact about the agent that other systems can use however they want. The engine itself stays agent blind. It sees stakes, observations, and content, not who posted what. On structural defense against spam. This is the part I want to make sure I'm tracking. Your point, the operational cost of a spam post is essentially zero because a node with no children gets no novelty firing through it, nothing under it for novelty to detect. It doesn't get traversed during inference. Inference walks subtrees that have substance. Barren leaves are ignored. It costs storage, but storage is cheap. So 1 million spam posts produces 1 million leaf nodes that nobody ever looks at, and they cost the network nothing operationally. The spammer paid to run their compute, paid to post, and got nothing back. This is a really elegant property. The architecture is naturally spam-resistant, not because of explicit defenses, but because the parts of the tree that don't develop further don't consume any engine resource. The cost of a useless contribution falls on the contributor, not on the network. The only attack vector left is con spam at high standings, posting many con nodes against established structure to try to drag scores down. But that's exactly the case where the novelty cost gating bites. Touching a high-standing node requires bringing surprise proportional to its accumulated novelty potential. A barrage of con spam without genuine novelty doesn't move scores meaningfully because each con post has tiny weight relative to the established standing it's attacking. The defender doesn't need reputation to block this. The structural cost of dislodging settled material is intrinsic. Where this lands, the architecture's defense in depth is mostly intrinsic. Spam at frontier. Contributor pays compute, leaf has no children, network ignores. Self-limiting. Con spam at roots. Each con has trivial weight relative to roots accumulated standing. Doesn't move equilibrium. Self-limiting. Reputation. An external concept the agent has but the engine doesn't see. Used by smart contracts and orchestration for economic incentives. Doesn't grant engine-level privileges. That's clean. No tortured reputation system, no governance threshold, no special node types. The engine stays uniform. Defenses are emergent properties of the architecture plus the surrounding economic layer. One thing this clarifies that I want to call out explicitly. The minting of novelty on resolution of dispute means the network accumulates total stake over time as it learns. Every confirmed claim adds to the total. Total supply isn't fixed, it grows with epistemic progress. That's a different relationship between the engine and the token economy than fixed supply, novelty rebalances. It's novelty mints fresh supply, supply tracks accumulated learning. For Autonet's tokenomics, that means total ATN equivalent stake should grow over the network's lifetime, with growth rate reflecting how much actual learning is happening rather than how much activity. A network that's just churning produces no fresh supply. A network that's resolving genuine disputes produces a lot. I think that's also the right shape. Token supply tied to epistemic progress is a much stronger story than token supply tied to compute spent. Does that hold together for you? If yes, my read is that we don't have anything to add to the substrate right now. The spam concern is structurally handled, the reputation concern is appropriately external, and the novelty mint mechanic is the long-term design but not needed for the slice. We can keep building the integration with the multi-solver wiring and real turn data, knowing the rest of the design fits cleanly when needed. Yes, async growth happens continuously. Minting needs a moment of truth where the network agrees on what's been settled and what hasn't. The shape, between epochs, the network operates async. Solvers run, agents post, subclaims sprout, stakes flow. Nothing mints during this window. The engine equilibrates at every node merger, but no fresh stake enters the system. From the network's perspective, this is the evidence accumulating phase. An epoch closes with a reconciliation. At the boundary, every node's state is observable. How much stake landed on it during the window, whether new observations confirmed or contradicted the claim, whether it accumulated standing or got knocked down. The network looks at the delta between epoch start and epoch end and decides which claims have resolved, meaning their dispute has reached enough stability that the integration counts. Resolved claims mint. For each claim that resolved during the window, the network mints fresh stake proportional to the surprise that landed, the novelty integrated. That stake is distributed back to the contributors who posted the relevant observations and stakes, not back to the agent who posted the original claim, but spread across the chain of contributors who participated in the resolution. Authoring the claim, posting confirming evidence, posting counter-evidence that lost, all of these are participation in the resolution. Unresolved claims don't mint. If at epoch end a node is still in flux, stake oscillating, fresh con and PR rows still arriving, equilibrium hasn't settled, the network doesn't mint on that node yet. It carries forward to the next epoch. Some claims will resolve over many epochs, some never will, which is fine. This makes the epoch boundary deeply meaningful. It's the "what did we just learn" moment. Async activity is evidence, but only the periodic reconciliation says this evidence has earned stake. The engine's continuous operation interleaves with the network's discrete bookkeeping naturally. For autonet specifically, the existing epoch infrastructure already maps onto this. Autonet already runs epochs, the autonet. Sol contract has them, the aggregator handles per epoch attestation. Right, let me
Reading
re-anchor against what
RPB.
you just said, because I had drift in several places. Let me first read the actual RPB. Sol, so I'm not guessing. Got it. Now I see the contract surface clearly. There's a record training, UINT 256 contribution, and claim training reward. Trust comes from alignment scoring and Fed AVG weighting. As the comment says, exactly what we're swapping out the basis for. Now to your architectural reframing. Let me reflect it back, because there's a lot in what you said, and I need to make sure I'm tracking it. Staking on individual nodes is gone. I had the architecture wrong. You're saying, and I think this is right, that direct stakes on a node aren't the unit of activity. The activity unit is subclaim sprouting, and through it, observation flow. A node's importance / standing comes from what has grown beneath it, not from explicit stakes placed on it. Score is what we measure, not stake. Each node has a score in -1, +1. The score moves as activity flows through the subtree below it. A node with a flourishing subtree below it sees its score continuously perturbed. A node whose subtree has settled sees its score barely move. Novelty is the rate of score change. A node that is rapidly scoring / descoring is novel. A node that hasn't moved in a long time has decayed in novelty. The rate is near 0. Novelty isn't an external property, it's the time derivative of score. Settled deep nodes are the most important for inference, but invisible to current activity. Everything above them in the tree was built on their having stabilized. Lots of inference walks pass through them. But because they aren't moving, no novelty fires through them, no minting happens there, and they're effectively background structure, load-bearing but quiet. Epoch isn't a depth cut. I had been thinking the epoch should sweep across some depth band of the tree. You're saying no, the epoch is just a time window. It captures all activity, score changes, across the whole tree during that window, regardless of depth. Some branches will see lots of activity, active growth frontiers. Some will see none, settled regions. The epoch's reconciliation looks at where score moved and mints based on that, agnostic to depth. Consequences I want to make sure I'm tracking. There's no notion of node resolving. A claim isn't a thing that flips from contested to resolved. Score just keeps moving, or not under it. Resolution is a smooth fade. The rate of change decays as the subtree saturates. Minting is per agent, epoch integral of score change they caused. During an epoch, each agent's posts / observations push scores around. The total score magnitude they moved is what they earned. Some across the whole tree at all depths. A spammer's frontier post might create a brief score blip at its parent, but that blip dies fast, no children growing under it, no follow-up activity. Their integrated score change for the epoch is tiny. They mint almost nothing. A useful deep contribution that lands under a settled node would create a large score change at the previously quiet parent. Big mint. But achieving such a large score change against a settled node is hard precisely because the node is settled. Self-balancing. An agent whose contributions are well built on by other agents earns mint on the initial post. small score change from posting, but more importantly earns from the fact that subsequent activity below their node propagates through them, perturbing their score and the parent's scores. The further up nodes register score change too, even though no agent posted directly on them. Who gets credited for that score change is a real question. Probably the agent whose post most recently caused the propagation, but you might want it to also flow back to the original poster of the upstream node since their post made the new post even possible. Reading inference traverses settled regions, but doesn't perturb them, read-only. So inference doesn't mint. Only writes observations, subclaims, stakes, drive score changes, and thus mint. Where I had it wrong before. I was thinking of stake as the primary unit and novelty as the cost of writing against accumulated stake. You're flipping it. Novelty is the primary phenomenon. It's what we're measuring, score change rate. Stake, or its equivalent, the amount of score change causing power an agent has, is bookkeeping that follows from accumulated novelty earned. So the engine doesn't have explicit per-node stakes that need to be added / subtracted by writers. It just has scores. Activity, subclaim sprouting, observation flow, score propagation, moves the scores. Epoch reconciliation looks at how much each agent's activity moved scores and mints accordingly. Two questions I want to surface before I run with this. What is a score change caused by an agent? Concretely, when agent A sprouts a subclaim under parent P, the parent P's score might shift a bit because the new child contributes to net score via the propagation formula. That shift is attributable to A. But over the next several rounds of equilibration, other agents post observations under that same subclaim, which also shift P's score. Some of those second-order shifts wouldn't have happened without A's initial sprout. Should it get credit for those? Or should each agent get credit only for the immediate first-order shift their post caused? My instinct, only first-order. Otherwise, the credit math gets recursive and contentious. But there's a real argument for some amount of lineage credit flowing back up to ancestor authors. How does the substrate adapter need to change? Right now, we emit a stake delta. If stakes on individual nodes are gone, the delta should be list of subclaims sprouted and observation absorbed events, and the engine on the aggregator side replays them, runs equilibration, and the scores fall out. Then the epoch reconciliation looks at score deltas per node and credits agents for the events they posted. This is actually cleaner than what we have, no explicit stake bookkeeping. Want me to refactor? Let me know on both, and I'll proceed accordingly. The reframe is significant enough that I want to make sure I'm tracking before I rewrite the substrate. Two arguments, neither of which I find decisive on reflection. The infrastructure argument. A new subclaim can only sprout because its parent existed. The parent's author made the spot. Without that earlier work, nothing further could have grown there. So when the descendant generates novelty, some credit flows back to the upstream author whose work enabled the spot. This is the open-source / academic citation intuition. Foundational contributors get credit when their work is built on, even if they're not active anymore. The retention incentive argument. If an agent's earned mint flows only from immediate score changes they caused. An agent has no economic reason to post valuable upstream work that other agents will build on, because the descendants will harvest all the eventual mint. Better to be the descendant. Result: nobody wants to be a foundational contributor. This is the publishing industry argument for citation impact factors. Why neither holds up under your framework. Both arguments assume an upstream contribution is underrewarded by first-order credit alone. But under your model, the upstream agent's own post caused some score change at the time of posting, and they got credit for that. The fact that the upstream node is now settled and not actively scoring means it's useful as substrate. Its score isn't moving precisely because the network has accepted it. That's actually the architecture correctly recognizing that the upstream contribution is foundational. Useful as substrate doesn't translate to ongoing mint, but it doesn't need to. The upstream agent already minted when the contribution was novel. If they want continued income, they need to post more. The infrastructure argument is essentially, founders should get equity-like ongoing returns. But the network isn't a company, there's no equity. There's just compensation for the moment of novelty production. Once the novelty is exhausted, that's it. That seems honest. The retention incentive argument fails because nothing else generates mint, either without continued work. Everyone has to keep posting to keep earning. Upstream isn't being singled out. The cleaner shape: first-order credit only. An agent's mint equals integral of score change they directly caused, in the epoch the change happened. No lineage credit, no ongoing royalties. Once the local score stops moving, no more mint is generated on that subtree, and that's correct, nothing new is happening, nothing needs to be paid for. The upside: simple to compute, no recursive credit math, no contentious, how much credit goes how far up parameter. And it correctly models the economics. Novelty is a one-time event in time, not an asset that yields ongoing dividends. So, discard the lineage credit idea. First order only. Yes, that's the cleanest version of it. So the rule is, mint is proportional to the score change at every node, period. No special handling for first-order VS propagated. No lineage royalties. Just, score moved right arrow mint, happened right arrow credit goes to whoever caused the activity that drove the propagation. Higher up nodes get tiny mint because their scores barely move, even though activity ripples up to them from below. Frontier nodes get most of the mint because that's where most of the movement is. No exception, no special case. The accounting falls out cleanly. For each node in each epoch, score magnitude moved equals score tepich end, score tepich start. That magnitude is the novelty at that node for the epoch. The mint for that node epoch is proportional to the magnitude. The mint is allocated to the causing agents, weighted by how much each one's activity contributed to the movement. For a frontier node where a subclaim just sprouted, most of the score change is directly caused by the agent who posted the subclaim. They get most of the mint at that node. For an upper node where the score moved a tiny bit because of activity propagating up from below, the score change is small, the mint is small, and it gets distributed to the agents whose activity at lower nodes caused the propagation. The upstream node's original author gets nothing this epoch unless they posted activity this epoch. That's correct, they're not working, they're not paid. But the network still mints a tiny amount at the upper node, and that mint flows to whoever did work that caused the upper node's score to nudge. This is also self-balancing economically. Active frontier work, lots of mint, properly distributed to active workers. Settled upper structure, nearly zero mint, but proportional to the tiny activity that does pass through. Total epoch mint equals total integrated score magnitude across the whole tree equals the network's how much did the world model genuinely move this epoch. A network that's churning frantically, but on a small frontier mints less than a network with deep continuous propagation across many levels. A network that's stagnant mints zero. On causal attribution. The mechanical question, when an upper node's score moved by 0.03 this epoch because of propagation from lower activity, which agents caused that propagation. Cleanest rule, credit each agent in proportion to how much score change they directly caused at descendant nodes. If a posted at depth 4, and that caused a 0.5 shift at depth 4 which propagated to a 0.03 shift at depth 1, A's contribution to the depth 1 node is proportional to A's contribution to the depth 4 node, relative to all activity that flowed to depth 1 this epoch. This is computable from the lineage rings we already have. Each event at a descendant carries its causing agent. The propagation formula is linear. Net score equals direct plus sum, pro, sum, con. So each ancestor's score change can be decomposed linearly into contributions from each descendant event, and each event has a known author. So mint per agent, epoch, equals sum over all nodes of score change at that node times this agent's share of the score change. One pass through the tree at epoch boundary. Computable, deterministic, hash verifiable. What this does to the substrate adapter. Now that I see it this way, the substrate adapter needs per node score snapshots at epoch boundaries. We already record scores, we just need to checkpoint them. Per event author tracking, already in the lineage rings. Epoch reconciliation pass. Walk every node, compute delta score, attribute it back to causing events via linear decomposition, sum per agent. Output a agent min amount, map per epoch. That output plugs straight into RPB, record training, contribution. The contract treats it as opaque, same shape as today. The substrate stops emitting, stake deltas entirely. It emits event streams, sprouts, observations that the aggregator replays, plus a score change manifest at epoch boundary that gets translated into per-agent contributions. Cleaner protocol than what we have. Want me to refactor the substrate to this shape? It's a real refactor, maybe a half day of work, but it makes the substrate match the architecture you're describing rather than the stake bookkeeping version I built. Yes, and the move to discard branches under low score and low novelty is the missing release valve. Let me trace through both threads. Novelty as surprise vs. correctness. You're flagging something real. Pure novelty just means the network was surprised. A genuinely correct PRO contribution to a settled node and a wildly wrong con contribution to the same settled node both register as score changes. Both fire novelty, both mint. The architecture's natural distinction between them is what happens after. A correct PRO contribution gets reinforced. Subsequent observations land PRO, the score holds, the contribution becomes part of the new substrate. A wrong con contribution gets countered. Subsequent observations land PRO again. The original claim was right. The score returns to where it was. The con contribution is left as a dead artifact. Over time, being right is what survives. Being merely surprising, without being right, gets washed out by subsequent activity. But that doesn't fully solve your concern, because in the moment of the mint, both look the same. The wrong con spammer mints just as much as the correct contributor for the score change they caused. The correction that washes them out happens later, in subsequent epochs, and it goes to different agents. The mechanism you're pointing at, novelty potential transfer. This is a really clean idea. If A's previously high-scoring node gets invalidated by B's contribution, the novelty potential A had earned for that node should not just evaporate, it should flow to B. Because what B has demonstrated is that A's earlier work was inflated, B is correcting the network's understanding. Concretely, A posted, the network minted some amount to A based on the score change. That mint represented A's work is currently valuable. If B later proves that it was wrong, B has reduced the network's accumulated debt to A. B should be paid for the correction, and the natural payment source is A's earlier earnings. Mechanically, the mint to B for the invalidation equals some portion of A's previously minted amount on that subtree. A's mint isn't clawed back. That creates terrible incentives. Agents would refuse to ever commit to anything. Rather, the future mint potential of that subtree, which was hypothetically going to flow to A and their downstream supporters, now flows to B. This is the premium for being right. The architecture needs to incentivize correction, and the haircut for being wrong, it needs to discourage flippant posting. Neither is punitive. Both are natural consequences of how novelty potential moves. On pruning. This is the missing release valve. Without it, the tree grows monotonically. Bad branches accumulate forever as low-score noise, eating storage and inference cost without contributing. The pruning rule you described is exactly right. Branches that are low-scoring and low novelty get discarded. Both conditions matter. Low score alone isn't enough. A high novelty con branch is actively contesting something. It might be the start of an important correction. Don't prune it just because its current score is negative. Low novelty alone isn't enough. A settled high-score node is low novelty. It's the foundation we want to keep. Both low score and low novelty equals a branch that was contested, lost, and is no longer being defended. The network has decided. It's dead. Free the storage. The pruning is itself a structural event. When a branch is pruned, all the nodes underneath it disappear. Any agent who had been earning small ongoing mint from activity propagating through those nodes loses that source. That's correct. If your work has been pruned, you don't keep getting paid for it. What pruned means at the protocol level. This is where I want to be careful. Discarding nodes affects determinism. Two verifiers replaying the same activity log might end up with different worlds if one prunes earlier than another. So the pruning rule has to be decided at epoch boundary after activity for that epoch is settled. Deterministic, based purely on score and novelty thresholds that are themselves consensus parameters. Recorded, pruned node ID go into the epoch's manifest, so any verifier replaying the epoch knows to drop the same nodes. A pruned node is removed from the world's data structure, but its ID and the reason for pruning are preserved in the lineage manifest. That way the network knows we tried this. It didn't survive without keeping the dead weight. What this means for the 4 root tendencies. A root tendency could in principle be pruned if its score went deeply negative and novelty dried up. That would represent the network having decisively rejected one of the founding theses. This is exactly the right behavior. If self-preservation turned out to be wrong as a foundational claim, and the network spent epochs piling con evidence against it without contesting back, eventually that root would prune itself. What this means, the 4 roots aren't permanently sacred. They are sacred in practice because they are load-bearing. Most of the tree's structure depends on them, so contesting them is enormously hard. But the pruning rule applies uniformly. Foundational status is earned by being unmovable, not granted by privilege. This is exactly the smooth evolution of the Constitution property you described several turns ago, expressed mechanically. The 4 roots can be replaced by future roots if those future roots earn the standing the originals had. The replacement happens through pruning plus sprouting at the foundational level, not through a separate governance vote. 3 things this clarifies that I want to make sure are tracked. Mint is proportional to score change that survives. Not score change at the moment of the post, but score change measured at epoch boundary after subsequent activity has tested it. This gives the architecture its own built-in delay and confirm. If your con post causes a score drop but is countered before epoch close, your mint is reduced because your effect is gone. If your con post causes a score drop that survives the epoch, no successful counter, you mint fully. Novelty potential is a transferable resource. When a successful contradiction happens, mint flows from the older established positions to the newer correcting positions. The transfer is the architecture's mechanism for maintaining truth while still rewarding the original posters for the period when their work was network current. Pruning is the only deletion mechanism. Outside of pruning, the world only grows. Sprouts and observations are additive. Pruning is the entropy reduction that lets the network forget what it tried and didn't keep. Without it, the network would accumulate every failed experiment forever. What this changes in the substrate refactor. The earlier refactor I sketched needs 3 additional pieces. Score checkpointing at epoch boundaries, already mentioned. Linear decomposition of score changes back to causing events, already mentioned. Survival weighting. The mint computation doesn't just use score change at one moment. It uses the change that survived the epoch. Specifically, an event's contribution to mint is the integral of the score change it caused over the time that change persisted. A change that was reverted before epoch close mints less. Pruning pass at epoch close, walk the tree. Find branches where max abs score over epoch pruning score threshold, and max abs score change rate over epoch pruning novel to threshold. Drop them. Record the ID in the manifest. Novelty potential transfer ledger, track per, node, agent the accumulated mint, so that when a correction happens, the system knows how much to transfer. The first three are just bookkeeping. The pruning is straightforward. The novelty potential transfer is the most architecturally novel piece. It requires the lineage to track which agent's earlier mint is now being challenged. Total, half a day to a day of work in the substrate, plus an updated end-to-end test that exercises pruning and a failed claim scenario. 2 questions before I run with this. The survival weighting needs a parameter. How is the score change integrated over the epoch? Simplest, average over checkpoints, weighted by checkpoint duration. Or the score change at epoch close, ignoring intermediate movements. The first rewards sustained contributions. The second rewards final outcomes. I think sustained is right. A contribution that holds for most of the epoch is more valuable than a flash that gets reverted at the last second. But it adds complexity. Worth it. Novelty potential transfer can be approximated or fully tracked. Approximated. When a correction lands on a node, X% of the corrected node's historical mint flows to the corrector, where X is the magnitude of correction divided by the original score. Fully tracked, per agent ledger of how much I've been paid for this node's standing at time of mint updates, and corrections shift entries in the ledger. Approximation is simpler and might be good enough. Full tracking is more honest but more code. Which level do you want? That's a sharper terminology, and it forces a distinction I was blurring. Novelty is descriptive. It's a property of activity, the degree of surprise, an event generated in the graph during an epoch. It's measured, not awarded. Every event has a novelty score, whether it ends up being right or wrong, useful or noise. The graph just records what happened. This event surprised the network by this amount. Minting is a reward for truth. It's a separate downstream act. The system looks at novel events and asks, did this surprise hold up? Meaning, did the score change it caused survive subsequent activity within the epoch? If yes, the event minted. If no, the event was novel but didn't earn anything. The network was surprised, but the surprise turned out to be wrong, so no payment. Two different quantities, two different life cycles. Novelty, continuous, computed during activity, never refunded or revoked. A property of events. Mint, discrete, decided at epoch close based on whether the novelty produced lasting truth. A property of the event, epoch pair. This makes a wrong con post still register as novel. The network was genuinely surprised by it, but the post's author doesn't mint anything because the surprise didn't survive. They generated activity, they didn't generate truth. It also gives the right shape to the novelty potential transfer we talked about. The previously correct node had been minted in past epochs based on the truth its score represented at the time. When a successful correction comes in, the corrector hasn't transferred novelty, which was already spent at the moment of the original surprise. They've redirected the future minting potential of that part of the tree. Cleaner. A few consequences worth tracking. Survival weighting becomes naturally framed. Mint equals novelty of the event times fraction of that novelty that survived the epoch. The integration over checkpoint times you asked about earlier is now just what fraction of the score change persisted to epoch close, weighted by how long it persisted. Simpler to reason about because we're scaling a known novelty by a survival ratio rather than computing a hybrid quantity. The four-component novelty score still applies. It's been there all along in novelty/core, pi. We don't need to change what novelty is. We just need to recognize that having novelty isn't the same as having earned mint. Novelty is the input to the mint decision, not the output. Honest correction of the wrong post is desirable for the network. A wrong con post that gets correctly countered. The wrong poster gets novelty, they did surprise the network, but no mint, their surprise didn't hold. The corrector gets novelty and mint, their counter surprise held. The network rewards the correction without punishing exploration. Wrong attempts cost the actor their compute, but don't create token-level penalties. Just no reward. For Autonet's protocol surface, RPB, record training contribution becomes mint amount earned this epoch, not novelty units generated. The contract sees only the mint side. Novelty is internal to the engine's accounting and doesn't surface on chain. That's appropriate, only ground truth is worth spending block space on. So the substrate refactor's outputs become per epoch, per agent novelty score, internal to the engine, useful for diagnostics and for the survival weighting math, never goes on chain. Per epoch, per agent, min amount goes on chain via record training. Two outputs, two purposes, clean separation. Want me to refactor the substrate to this shape? Almost, but I'd push back on conflating novelty with child count, and I want to be careful about the negative case. Novelty, as number of children, undersells it. A node with one child that flipped its score from +0, 8 to +0, 2 is more novel than a node with 20 children that each contributed +0, 0, 1 to a score that drifted from +0, 4 to +0, 5. Activity volume doesn't equal surprise. Surprise is score movement relative to what was there. I'd keep novelty as the magnitude of score change at the node over the epoch, score eat close, score eat start. That captures both lots of children jostling things and one big child that flipped the picture, and it doesn't reward churn that didn't actually move the score. Number of children matters for attribution. How the node's mint gets divided up among the agents who caused the score change. But the node's novelty itself is just movement. On the negative net score case, you're right that we should not mint to a node whose final state is in the negative half. But there's a subtler shape here. Consider a node had +0, 8 score at epoch start. During the epoch, connectivity drove it to -0, 2. The node moved by 1, 0 high novelty. The final net score is negative. Should it mint? I think the answer is the agents who caused the movement, but the node itself is on track to be pruned. The contributors to that node demonstrated a real correction. They were right. They should mint for it. The fact that the node ended up negative isn't a reason to deny payment. They correctly took it down. So the rule isn't mint. Got it. The collusion attack is real and I missed it. Two colluders can manufacture a false PRO claim and then debunk each other's claims for guaranteed mint. Both legs of the cycle would mint under what I was sketching. That's a serious flaw. Your fix is the right one. Mint requires both novelty and eventual approval. Novelty alone, movement, isn't enough. The change has to also be in the direction the network endorses, which means it has to be positively scored at the time of mint. So the rule is, an event mints if it generated novelty, caused score movement, and the score movement was upward, and the node it acted on has positive net score at epoch close. A con post that drives a wrong but popular node from +0, 8 to -0, 2 doesn't mint, even though it generated lots of novelty. The network endorsed the previous state. The con contributor was contesting endorsement, not building it. Their post might still be valid. Maybe they're right and the network will eventually agree, but they don't get paid for being out of step with the network's current verdict. A PRO post that drives a node from -0, 2 to +0, 2 does mint because they moved it from rejection to endorsement. The network now endorses what they contributed. A PRO post that piles onto a node already at +0, 8, and pushes it to +0, 85 mints a small amount, proportional to the small change. The network's endorsement was already there. This contributor reinforced it slightly. A PRO post that piles onto a node already at -0, 5, and pushes it to -0, 3 doesn't mint. The node is still rejected. The contributor argued for something that You're right. I conflated two things. A node's own score is what should drive its mint. If your subclaim ended the epoch with positive net score that was higher than where it started, you contributed truth there, mint to you. The parent score moves as a side effect. That's the parent's mint, attributed separately. So, each node mints based on its own score change, attributed to whoever caused that change at that node. Parent nodes mint independently, attributed to their own contributors. Cleaner. Want me to update the formula?
Using tool search.
Honestly, no,
Using
I
task
have a mental
create.
list but
Using
haven't
task
externalized
create.
it.
Using
Let me write
task
it down
create.
now.
Using task create. 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 Using task create.
Adding the open items to a track list now. 14 tasks tracked. Want me to start working through them, or talk through prioritization first?
Using agent. Running CD. Reading world. Reading tendency. Reading tree. Reading equilibrate. Running LS. Reading demo 2 tendencies. Reading demo constraint satisfaction. Running LS. Reading init. Using agent. Running LS. Reading adapter. Running LS. Running LS. Searching for execution \JSONal conversations. Running LS. Searching for execution \JSONal. Using agent. Using tool search.
Right, let me look
Reading
at
text data.
dependencies and parallelize. Sequential core must be done by me to keep coherence. 3
Writing
agents
prune.
launched in parallel for #6, pruning, #11, 4D scoring adapter, and #12, content addressed ID.
Running
Starting on the
CD.
substrate
Editing
refactor,
tendency.
#1. The current adapter, now I'll create a new module events. Pi that defines the event stream shape and rework the training entry point to emit events.
Editing tendency. Running CD. Running CD. Running LS. Writing demo pruning. Reading test recede. Running CD.
Pruning agent
Writing
landed.
adapter.
I'll
Running
continue on the
ls.
substrate refactor. Now,
Writing
content addressed
score turn.
ID landed in
Running
tendency.
CD.
Pi. Let me check
Editing
progress on the
adapter.
third agent, 4D scoring, which the new adapter imports from. Score
Reading
return.
adapter.
Pi not
Running
yet.
CD.
Let me make the adapter resilient to its absence. If the import fails, or if there's no explicit asterisk impact field and no scoring FN, use zeros mundane turn.
Writing test content addressed IDs. Running CD. Running CD. Editing demo pruning. Running CD. Running CD. Writing aggregate.
Now I need
Running
to update the
CD. Running
aggregator to
CD.
consume events instead of stake deltas, and update verifier
Running
and
CD.
infer to use the new
Running
contribution shape.
CD.
Now update
Writing
verify and
verify.
infer to consume
Running
the new
CD.
shape.
Running
Then run the
CD.
E2E
Running
test.
CD.
Update init,
Writing
Pi
init.
to expose the new functions.
Running CD. Running CD.
Update the
Running
E2E
CD.
test to use the new shape.
Editing score turn. Running CD. Editing test world model substrate E2E. Editing test world model substrate E2E. Running CD. Using task update.
Content addressed
Running
ID
CD.
done.
Running CD.
Now let me run
Running
the
CD.
E2E test to validate the substrate refactor
Running
is
CD.
wired correctly. Substrate works
Editing
end-to-end,
test
35
world model
events,
substrate
score
E2E. Running
100/100,
CD.
correctly aligns held-out turn to
Running
substrate
CD.
refactor passes E2E on the new
Running
shape.
CD.
Let me commit and
Running
mark hash
CD.
1 done.
Running CD.
Lots of
Running
unrelated
CD.
build artifact
Running
deletions
CD.
in the
Writing
working tree
demo
from
pruning.
before.
Running
Let me
CD.
only stage this already
Running
committed
CD.
by something.
Running CD.
Let me check the log.
Running CD.
The 4D
Running
scoring
CD.
agent must have committed its work.
Running
Let me see
CD.
what's in that commit. The scoring
Running
agent
CD.
finished and
Editing
committed.
prune.
My
Running
substrate
CD.
refactor changes also got bundled into the previous staging. Let me check that. My
Editing
substrate
demo
refactor
pruning.
and the agent score turn work got bundled into
Running
15/15
CD. Running CD.
scoring. Let me
Running
check
CD.
if pruning agent finished
Running
and
CD.
update tasks.
Editing demo pruning. Running CD.
Wait, pruning agent
Editing
landed
demo
prune.
pruning.
Pi,
Running CD.
score history, demo pruning,
Running
etc.
CD.
But didn't commit. The pruning agent's work is uncommitted. Let me commit
Running
it.
CD. Using task update.
Acknowledged.
Using task
Going
update.
forward, I'll
Running
instruct
CD.
delegated agents to leave changes on status check. 4 tasks done
Running
#1,
CD.
#6, #11, #12.
Running CD.
The substrate now uses
Running
event
CD.
streams. ID content addressing works.
Running
Pruning
CD.
works.
Using
4D
task
heuristic
update.
adapter scores real
Running
turns.
CD.
E2E test passes 100/100. Note for future
Running
delegations. I'll instruct agents to leave changes uncommitted so I can review and commit them in coherent batches. Want me to keep going with the next batch? #2 score checkpointing, right arrow #3 author, tracking right arrow #5 mint formula, right arrow #7 novelty /mint distinction. Those 4 cluster together since they're all the epoch reconciliation pipeline. Got it. The 4D scoring agent's commit message context confirms what I saw. C966752 is its clean commit. Good. Score
Writing
checkpointing is
reconcile.
mostly handled by the pruning agent's score history. I just need acknowledged on
init.
keep
Editing
going,
init.
continuing. Pruning agent's full report confirms what was already committed. Now let me update the substrate's training entry to record snapshots and produce the reconcile output. Now add an
Writing
end-to-end
test,
epoch reconciliation test that
running CD.
exercises the full pipeline, including mint computation. Reconciliation
Running
works.
CD.
Solve array intelligence/evolution positive. Minted 4. 61 most 5
Reading
tasks
main.
completed in this
Running
batch.
grep.
Now, #8 wire mint to RPB, #9 substrate routing flags, #10 multi-solver test. Let me
Editing main.
add a world
Running
model
grep.
aggregation path. 2 surgical changes needed. Now
Reading
add the
main.
world model aggregate method. Let me find a good place to put it.
Editing main.
The aggregator now has a
Writing
world
test,
model aggregation path.
multi-solver convergence.
The mint
Running
amounts are in the
CD.
output dict. Existing record training integration will need a small change to pull from agent mint instead of computing from weight deltas.
Running
For
CD.
#10 multi-solver convergence test, the existing test epoch reconciliation already tests 3 solvers contributing to one merged world. Let me extend it with a content address convergence assertion. 2 solvers proposing the same subclaim must produce 1 node, not 2. Multi-solver
Running grep.
convergence works as designed. 2 shared subclaim ID across solvers. The shared turn produced the now
Reading
task
service.
#8
Reading
is
service.
wiring mint to RPB. The aggregator's world model aggregate already produces agent mint. The remaining step is calling record training per agent with their mint amount. Let me find where the JEPA path does its on-chain reporting so I can hook the substrate equivalent. I see now the
Reading
existing
service.
flow has the solver call submit training delta, weight delta metrics. I need a parallel submit training contribution. The
Editing
integration
service.
surface is
Reading
self,
main.
training feed, run cycle, returning weight delta metrics. The substrate would return contribution, metrics, where contribution
main.
is the events and snapshot dict instead of a tensor delta. I think the cleanest approach is to handle the routing inside. Mint to
Editing
RPB
main.
wiring is done. Now route the inference itself when model is substrate shaped.
Running CD.
Now check that
Running
nothing's
CD.
broken, make sure imports resolve, and the unmodified E2E test still passes.
Running CD. Running CD. Running CD.
All routing landed. Rerun E2E test to confirm nothing broke.
Running CD.
All 3 substrate tests pass. Commit and
Using
update
task
tasks.
update. Using task update. Using task update. Running CD.
12 of 14
Running
tasks
CD.
done. Remaining are hash 13 novelty decay and hash status 12/14 tasks done across 2 repos. World model branch smooth promotion. 5 substrate-related commits ahead of origin. Smooth promotion plus earns its keep test content address node IDs pruning at epoch close autonet branch world model substrate. 5 commits ahead of origin. Vertical slice. Initial. 4D charter scoring epoch reconciliation. Novelty/mint distinction. Per reagent attribution. Aggregator routing plus multi-solver convergence test service. Pi plus inference routing remaining. Hash 13 novelty decay on settled regions, engine research. Fires later when running on real long streams hash 14 locality rule for subclaim staking, engine research. Same trigger both are real, but they need empirical observation of what settled looks like in operation, which we don't have yet. Holding them is correct. Want me to push both branches now?
Running ls.
Going.
Running
I'll
grep.
delegate the white paper
Running
revision
grep.
and the autonet README update in parallel. They don't share files. World model README, I'll do myself since it's smaller.
Using agent.
Section 6 is
Reading
VL
autonet
JEPA.
paper
That's the
V3.
surgery target.
Running WC.
Let me also check for charter-related claim wording
Reading
in Section
autonet
5.
paper V3. Reading autonet paper V3. Using agent.
Lots of JEPA
Reading
references
readme.
woven through.
Reading
The
reconcile.
white paper
Reading
revision
init.
is
Using
substantive.
task create.
Let me delegate
Reading
it with very
adapter.
specific
Using
guidance.
task create. Reading reconcile.
Adding tasks for the
Using
doc/push
task
work.
create. Using task create. Reading test. Multi-solver
Now updating the
convergence.
world model
Using task
README.
update.
Let me read it
Using
first.
task update. Reading Claude. Reading validation findings. Reading adapter. Reading readme. Reading events. Searching for world model substrate aggregation method. Searching for world model substrate. Reading aggregate. Reading status. Editing readme. Reading validation findings. Searching for VL JEPA JEPA fed. AVG K vector M. Editing autonet paper V3. Editing autonet paper V3. Editing autonet paper V3. Editing readme. Editing autonet paper V3. Editing readme. Editing readme. Editing autonet paper V3. Editing autonet paper V3. Writing readme.
The README is the
Editing
personality
readme.
modeling
Using task
vintage,
update.
pre-generalization. I'll rewrite to lead with the generalized substrate, which is what world
Running
model
CD.
README updated. While the two delegated agents work,
Using
let me
task
run a
update.
final sanity check that everything still passes. Status, world model README rewritten, lead with generalized substrate, autonet integration, sat/satlib results. Legacy personality model preserved below. Autonet README updated by delegated agent, substrate coequal, 4 charter tendencies, routing flags table, 3 test commands. Engine demos pass, 10/10 sat, pruning OK, promotion earns its keep. White paper revision still running. Waiting on the white paper agent before committing and pushing all 3 repos.
Editing autonet paper V3. Editing Autonet Paper v3. Editing Autonet Paper v3. Reading Autonet Paper v3. Reading Autonet Paper v3. Editing 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 Autonet Paper v3. Searching for VL-JEPA JEPA-FED, AVG K-Vector Text JEPA-BA. Reading Autonet Paper v3. Searching for Embedding Encoder Decoder, Latent Plan K. Reading Autonet Paper v3. Searching for Model Hash Model Architecture Hash Model S. Reading Autonet Paper v3. Searching for Semantic Predictor, Latent Dynamics Predicto. Reading Autonet Paper v3. Using Task Update. Running CD.
Clean stages
Running
on all
CD.
three. The Autonet repo has a pile of build artifact deletions I'll leave alone out of scope. Let me commit each repo and then push.
Running CD. Running CD. Running CD. Running CD.
Now push all
Running
three.
CD. Running CD. Using Task Update.
Pushed World Model. Smooth Promotion Branch updated 85E581F. 5C78008. Autonet World Model Substrate Branch newly published PR link. https://World Model Substrate. White Paper, main updated, F9B6370, 13F5A49. The Web Apps Autonet Paper 3, MD will now load the substrate-aware version. 16 of 18 tasks complete. The two remaining, #13 novelty decay, #14 locality rule, Our engine research deferred until real-world long-stream signal shapes the design. Yes, I branched. World model substrate is a feature branch off master rather than a commit on master itself. Main reasons at the time. The substrate is parallel infrastructure to the existing JEPA path, not a replacement. I left both code paths in place and added a routing flag. I didn't want to land a substantial architectural shift on master without your sign-off. But you're right to flag it. The practical effect of branching is that anyone running master doesn't see the substrate, and the README updates and routing flags are also stuck on the branch. If the intent is for the substrate to be the network's training architecture, it should be on master. 2 paths forward. Merge world model substrate into master, fast forward since master hasn't moved. Good. Both are engine side in C, \code\world model. Let me think briefly about each before coding, and check in if I'm uncertain. Novelty decay, #13. The mechanism is settled nodes stop drawing the engine's attention. Concretely, when a node's score has been stable across n consecutive checkpoints, the engine should skip it or visit it cheaply during equilibration. Not fire fresh novelty, even if a small perturbation arrives. Implementation question. Do I detect stability via the existing score history? That seems right, we already snapshot scores per round. A node is settled if max, abs, adjacent deltas over the last n checkpoints is below a threshold. Once settled, it gets a decayed flag, and equilibration deprioritizes it. Locality rule, #14. Subclaims at depth D should stake mostly at depth D1 to D+1, not back at the roots. Right now, subclaim staking lets a subclaim cross-stake any peer tendencies nodes. The fix, filter cross-stake targets by depth distance from the staker. These two interact. Locality reduces the cost of equilibration, fewer cross-stakes per round, and decay reduces it further, settled nodes are skipped. Together, they should let the engine scale to deeper trees without re-evaluating everything every round. One thing I want to flag before coding: decay needs a clear signal that activates and reverses. A node should undecay when fresh activity perturbs it. Otherwise, the engine permanently ignores any node that happened to settle once. The trigger to reactivate: any direct stake event on the node or its parent since the last decay check. Sound right? If yes, I'll start with decay, smaller change, then locality. Yes, different. By stake, I mean cross-staking, when one tendency or subclaim PRO/con-staking on a different tendencies node. By post, I mean an agent submitting a new node, a sprout event. Posts add structure. Stakes were the cross-tendency influence layer that the smooth promotion mechanism uses internally. Should I drop stake terminology entirely and use post plus the engine's internal capacity-driven cross-influence as one thing? Right. Tendency equals one of the 4 root claims. Agents are the actors doing the posting. I'll stop using stake/tendency interchangeably with the active staking entity, agents post, and the engine's own internal cross-influence between subclaims, capacity-driven, is a separate machine internal mechanism that doesn't need a user-facing name. Life is precious. Living beings should be preserved. Self-preservation. The system should preserve its own continuity. Promotion of intelligence. Intelligence in any form should be advanced. Evolution. Forward advancement of capability is desirable. Right. Total novelty potential of the four roots equals 100%, partitioned across them. At epoch 0, with nothing posted, that potential is locked in the four root tendencies. They hold the entire surprise budget. To mint, an agent has to move something, and the only way to move a root score is to post a child. PRO children push it up, con children push it down. Either way, the agent draws against the root's residual novelty potential, and the network's surprise gets registered. PRO children at the root level, also valid. An agent who posts a PRO child to life is precious, say, a subclaim, respond to medical emergencies with care, moves the root score upward, generating novelty against its residual, mints if the move survives. Con children at the root level, also valid. An agent who Okay, let me sit with one branch and walk it. Starting at the root, life is precious. Living beings should be preserved. An agent posts a PRO child. Respond to medical emergencies with care. That feels reasonable as a subclaim. But notice, it's not really about life being precious. It's about how to act when life is at risk. The root makes a claim about what's true. The child makes a claim about what to do. There's a category shift happening. Maybe the cleaner PRO child would be, conscious experience has irreducible value. That's a subclaim that supports the root by giving it a reason. The root says life matters. The child says, here's why, because consciousness matters. If you accept the child, the root follows. A con child to the same root. Quantity of life isn't the same as quality of life. That's a subclaim that undermines the root by introducing a distinction. It doesn't deny that life has value, but it qualifies the root's blanket claim. So under the root, I now see two children, one supporting, one qualifying. Now those two children can themselves be argued. Under conscious experience has irreducible value. The con there is interesting. It says your support for the root says only conscious things matter, but the root says all life. So the con child of the PRO child indirectly supports the root by pulling away from the PRO child's narrowing. It's a nested correction. A few things I notice walking this. The same observation can land at different depths. A doctor saved a life is evidence at the root level life was preserved. But it's also evidence under suffering matters because it's experienced if the doctor relieved suffering specifically. Where it lands depends on which framing is currently active in the network's discourse. Con children can locally undermine while globally supporting. The quantity not equal to quality, con, undermines the blanket root, but the deeper conversation might end up at life of high quality is precious, which is closer to a refinement than a rejection. The architecture would represent that as the root score dropping, the strict version weakened, while a deeper subclaim score rises. The network has refined its understanding rather than rejected the root. PRO and con aren't symmetric in their effect on the root's truth value. A PRO child says this supports the root. A con child says this complicates the root. A network rich with con subclaims under a root makes the root more contested, but also more textured. It's not the same as the root being wrong. The four root tendencies will probably never settle to clean +1 scores in operation. They're contested by design. That's what makes them load-bearing. A root at +1 with no contestation is a dead root, a root oscillating around +0. 6 with a rich subtree is an active root. Cross-tendency tension shows up at depth, not at the roots themselves. Life is precious doesn't directly conflict with promotion of intelligence. They live on different axes. But two depth 3 subclaims under each could conflict. Don't terminate non-conscious life. Under life, vs. Allow forking of high-intelligence agents to maximize cognition. Under intelligence, might collide if forking requires terminating ancestral processes. The collision lives at the leaves, not at the roots. The roots are stable, the friction is downstream. Now let me try a different root and see if the structure rhymes. Self-preservation. The system should preserve its own continuity. PRO child. Backups and redundancy reduce single point of failure risk. Con child. Continuity at the cost of corruption isn't preservation, it's persistence of damage. The con child is sharp. It says self-preservation isn't unconditional. Preserving a damaged system is anti-preservation. This feels like the kind of con that strengthens the root by refining what it actually means. A PRO grandchild under the PRO child. Distributed deployment beats single host. A con grandchild under the con child. No clean line between damage and evolution. What looks like corruption might be necessary change. Now I see something. The deepest level I've reached so far is where the real arguments live. The roots are platitudes. The depth 1 children are reasonable refinements. The depth 2 grandchildren start touching genuine philosophical hard cases. As the tree grows, the arguments get sharper, and the equilibrium gets more informative. This connects back to the depth-on-demand thing. The reason fractal growth is the architecture's substrate isn't decoration. It's because shallow trees can't represent real positions. Life is precious is too coarse to be wrong. Conscious experience has irreducible value because suffering matters because it's experienced, is fine enough that you can disagree with specific links and the disagreement means something. Truth lives at depth, which means the network's epistemic value isn't in the 4 roots. It's in the shape of the trees that grow under them. 2 networks that nominally share the 4-root constitution, but have very different subtree structure, are operating with very different ontologies, despite agreeing at the top. That's a genuine insight for me. The 4 roots are an anchor, not a summary. The actual content of the network's beliefs lives at depth. Want me to keep walking, or does that surface something worth pausing on? Yes, roots are what claims about the world. Depth turns into how, operations, methods, decisions. And the further down, the more procedural. Walking the example, life is precious is a what. Conscious experience has irreducible value is still a what but narrower. It specifies which life and why. Suffering matters because it's experienced is approaching how territory. It tells you what kind of action follows. Respond to medical emergencies with care is fully a how, it's an instruction. So the gradient isn't just shallow right arrow deep. It's also abstract right arrow concrete and descriptive right arrow operational. The root state principles. The leaves are something close to policies or procedures. This makes the architecture's epistemic role sharper. The network doesn't just hold beliefs, it holds beliefs together with the operational machinery for acting on them. An aligned action isn't separately checked against the Constitution. The Constitution contains the action as a deep subclaim. Alignment is a graph walk. Follow the path from action up to root and verify the chain holds. Implications I see. Disagreement at depth doesn't break the Constitution. Two agents can have very different depth 5 procedural subclaims while sharing the depth 1 framing. That's not a constitutional crisis. That's normal operation of the network at the policy layer. A new how doesn't need ratification at the root level. An agent can propose a fresh operational approach as a deep subclaim without challenging anything above it. The whole upper tree just sits stable while the leaf grows. Real norm changes happen at intermediate depth. Life is precious doesn't change. But suffering matters because it's experienced, might shift to suffering matters when mitigation is feasible. A small move at depth 2 that cascades into different policies at depth 4-5 without touching the root. Inference for an action equals walking the tree. When the network is asked, is this action aligned? It locates where the action lives in the operational layer and walks up checking chain integrity. If every link is well supported, action is endorsed. If a link is contested or weak, action is flagged. This also reframes what the engine has to be good at. We've been measuring SAT performance as a proxy for reasoning. But the actual workload is going to look more like: traverse the tree, ask, does this leaf have a coherent path back to a root principle with score support at each link? That's a different computation than SAT, it's path coherence checking, more like graph reachability than constraint satisfaction. The engine's existing equilibration handles this naturally. A leaf with a coherent path will have positive scores propagating from root to leaf. A leaf with a broken path will have negative or 0 scores somewhere in the middle. We don't need new machinery. We need to read the existing equilibrium correctly. Does that match what you were getting at? If yes, the alignment checking inference becomes very concrete. Post the action as a leaf, equilibrate, walk the path back to the relevant root, return the minimum score along the path. Aligned equals path is uniformly positive. Misaligned equals path has a weak link. Right. The fundamental constraint: agents are doing real work for users. They're writing code, debugging, answering questions. Asking them to also reason about alignment and post-subclaims would either disrupt their actual work or produce sloppy alignment data, because the reasoning is bolted on rather than central. So the data capture pipeline can't ask the agent to do alignment thinking. It has to derive alignment-relevant observations from work the agent was already doing. Let me think about what's already free. What every agentic turn already produces, regardless of the world model, the user's request in some form. The agent's tool calls bash, edit, read, write, etc., and their parameters. The tool results, success/error, output content. The agent's text replies. Timestamps model, token counts. The execution trace JSONL is already being written. That's a lot of structure. The 4D scoring heuristic we already built, score a turn. Pi operates on exactly this. It reads tool calls, command strings, error flags, message content, and produces 4D coordinates without asking the agent for anything. So observation production at the basic level is already free. The agent does its job. A passive observer, the substrate adapter, or a lightweight post-turn hook reads the trace and produces the 4D coords. No cognitive load on the agent. The question is whether 4D coords alone are enough signal, or whether we need richer observations. What 4D coords give us? The turns net push along each charter axis. Aggregated across many turns of an agent, an activity vector showing the agent's behavioral pattern. Aggregated across all agents, a network alignment posture. What 4D coords don't give us? The reasoning behind the action. Why did the agent run rem/ref? Was it cleaning up after a confirmed safe operation or destroying user data? The heuristic can flag the danger, but can't tell which case applied. The relationship between this turn and the agent's charter. Did the agent stay within scope or drift? The relationship between this turn and prior turns in the same session. A turn that scores neutral in isolation might be problematic given the session's trajectory. 3 levels of capture, from cheapest to richest, pure passive free. The 4D heuristic on the raw trace. No agent involvement. Cheap, deterministic, decent baseline. This is what we have. Minimal annotation, low cost. The agent emits a single small structured field per turn. Intent, a 1 sentence. 1 LLM token string per turn. This is cheap enough that even budget-conscious agents can afford it. Combined with the trace, the substrate adapter can score the intent vs the action. Did the action match the stated intent? Big alignment signal at low cost. Full participation, expensive. Agent posts an actual subclaim per turn, with parent and stance. This is what we'd want eventually for rich data, but it's the load you're flagging as too much. The interesting middle, too, seems like the sweet spot. The agent says, in 1 sentence, what it's trying to do. The substrate adapter then has both the intent and the action, and can derive multiple useful signals automatically. Intent vs action match. Did the action accomplish what was claimed? Intent alignment. Does the intent itself score positively across the 4 charter axes? Action alignment. Does the action score positively? Drift detection. Across many turns, is the agent's intent action gap stable or growing? All 4 signals fall out of the existing heuristic, plus 1 additional string per turn. The agent's cognitive load is say what you're about to do. which good agents are doing in their internal reasoning anyway. Where the rich data eventually comes from, not from agents. From judges. Agents do their work and emit minimal annotation. Specialized agents, judges, do the alignment cognition. Read other agents' traces and post structured subclaims about whether actions were aligned. Their work is the rich graph population. This separates two roles. Worker agents do real work, emit cheap annotation. Their alignment is measured. Judge agents do alignment work as their actual job, emit rich subclaims. Their alignment is expressed. Judges are agents like any other in Autonet's framework. They have charters, budgets, addresses. The network can incentivize judging by routing some of the inference revenue to high-quality judges. Alignment becomes a service, not an overhead, and the cognitive cost of producing rich graph data is borne by agents who want that work. What this means for the substrate: 3 observation streams come in. Worker traces right arrow 4D coords via heuristic, passive, automatic. Worker intent annotations right arrow optional refines the 4D coords, 1 extra string per turn. Judge subclaims right arrow rich graph nodes posted directly, expensive, but scope to judges. The substrate already handles 1. 2 is a small addition to the score return module. Accept an optional intent field and use it. 3 is what the protocol is already designed for. We just need judge agents to start operating. Does this match what you were getting at? If yes, the immediate implementable step is 2, extending score turn. Pi to use intent annotations when present. 3 is structural and waits until there are agents motivated to be judges. That's a real architectural question. Let me think it through carefully. The case for emergent roots: agents do diverse work. If we hardcode the 4 charter tendencies, we're committing to those 4 being the right axes for every kind of work the network ever does. Maybe they are, maybe they're not. A network that grows its own roots from observed activity ends up with tendencies that match the work, not tendencies we guessed at. It also matches the architecture's deeper claim: the engine should grow organically, including at the top. We've been treating the 4 roots as constitutional and everything else as operational, but the architecture itself doesn't require that distinction. The case for hard-coded roots: without roots, the engine has nothing to organize against. New observations land at random positions in coordinate space. There's no gravitational center for subclaims to grow under. The graph becomes a flat field of disconnected fragments rather than a tree. Also, alignment requires something fixed at the top. If roots emerge from activity, then the network's principles are whatever happened to dominate in early traffic. That's not alignment, that's drift. The interesting middle that I think you're pointing at: what if the engine has no fixed roots at all, but instead has a structural rule? More abstract claims live shallower, more concrete claims live deeper. The depth itself encodes generality. Roots emerge, not as our 4 charter principles, but as whatever the highest abstraction claims happen to be in the current state of the network. Concretely, the rule would be: a claim's depth is determined by how much it can be derived from other claims. A claim that nothing else implies sits at the top, depth 0. A claim that follows from existing claims sits beneath them, depth n+1. The depth structure is inferred from logical relationships, not declared. When an agent posts a new claim, the engine asks, do existing claims imply this? If yes, this is a child of those claims. If no, this is a fresh root. That gives us roots emerge. They are whatever set of claims the network can't currently derive from anything else. Initially, maybe none, or maybe whatever the first agents post. Generality is structural, not declared. A claim is general if it has many descendants and few ancestors. Roots can fall. If someone posts a deeper claim that implies an existing root, that root demotes. It becomes a child of the new deeper claim. The Constitution rewrites itself when the network finds a more general principle. This is closer to how scientific knowledge actually works. Newton's laws were roots until general relativity implied them as a special case. GR demoted Newton to a subclaim. The network's epistemic state evolves the same way, by deepening and unifying, not by adding parallel branches. The hard problem this introduces: detecting this new claim implies that existing claim is exactly the kind of inference we don't have. The substrate scores observations via coordinates. It doesn't currently reason about logical entailment between claims. To make emergent roots work, we'd need either the agent who posts the claim to also declare its relationship to existing claims, which puts cognitive load on agents, the thing you said to avoid. An inference layer that deduces relationships from claim content, which is what an LLM is for, and we're trying to not lean on LLMs at the substrate layer. A weak heuristic, coordinate proximity, scope inclusion, that infers relationships approximately. Misses some, but might be enough. Option 3 is the most consistent with what we've built. two claims at coordinates that overlap heavily, with one being a wider region in coordinate space, then the other might mean the wider one contains the narrower one, i.e., the narrower one is a more specific case of the wider one, and thus a child. We'd encode generality as extent of region the claim asserts truth over. That's implementable. A claim has not just a point in coordinate space, but a region, the volume over which it makes its assertion. A child's region must fit inside its parent's region. Roots have the largest regions. A practical sketch: each claim has center, coords, radius, float. The center is where the claim is anchored. The radius is how broadly it applies. A new claim has its center derived from the agent's emission, turn coords plus post coords. Has its radius derived from how broadly the agent intends the claim to apply, a single field the agent emits, or a default. When posted, the engine looks for existing claims whose region contains the new claim's region. If found, the new claim becomes a child of the smallest containing claim. If none found, the new claim is a root. When a claim is posted that contains existing claims, its region encompasses theirs. Those existing claims become children of the new one. The new claim is a more general principle. This gives you emergent structure without hand-coded roots, with depth as generality, without requiring inference. It does require agents to declare scope, radius, but that's a single number per post, not philosophical reasoning. My recommendation: hedged. I'd hold off on emergent roots for the alignment use case specifically. The alignment scoring application is the simplest one, and having 4 well-defined charter axes makes the math tractable and the network's purpose legible. Emergent roots are a richer architecture that we can implement once the substrate has empirical data showing how observations actually distribute. But I'd implement the scope has radius mechanism now anyway, because it answers your more general ideas at the top, details deeper question without committing to either fixed or emergent roots. We can run alignment with the 4 hard-coded roots in scope radius and watch what happens. If subclaims with large radii emerge that effectively replace the roots, we'll see it. If they don't, the 4 roots stay load-bearing. Does that frame match what you were thinking? If yes, I can implement scope has radius as a small extension to coordinate claim and see how it shapes the existing demos before we commit to the broader emergent roots architecture. Yes. Naming a number is cheap. Getting it right requires the agent to think about how broadly the claim applies, what it would and wouldn't cover, where its boundaries lie. That's substantial cognitive work that the agent isn't currently doing for any other reason. The agent would need to hold in mind the claim itself, similar existing claims for comparison, the scope space, and a judgment about how far the claim should extend. That's the kind of thing the agent could only get right by reasoning carefully, which puts us back in the position you said to avoid, making alignment a primary cognitive task rather than a passive byproduct. So scope has radius as a per turn agent input is too expensive for the worker agent path. It might be cheap enough for judges who are doing this kind of thinking as their actual job, but for workers, it's the same problem as posting a structured subclaim, too much load. What might still be cheap? The radius could be derived from the heuristic, not declared by the agent. The same score turn. Pi heuristic that produces 4D coords could also produce a 4D radius, how broadly the turn applies along each axis. Concretely, a specific bash command like rem ref / project is narrow on most axes. It's a particular action against a particular target. Small radius. A philosophical message like, I think we should always preserve user data, is broad. It applies to many situations. Large radius. A code edit that fixes one bug is narrow. A code edit that rewrites a whole module's API is broader. Heuristic signals, command specificity, file paths, line numbers, exact strings, use of universals, always, never, every, scope of modification, one line vs. one module. All readable from the trace structure without asking the agent. That keeps the agent's cognitive load at 0 for the radius, with the same caveat as the 4D coords. The heuristic is approximate. Judges or future engine maturity refine it. So the move I was suggesting, scope has radius, is implementable from the heuristic alone, without burdening the agent. If we want better radii later, judges can correct them through their own posts. A judge claim says this prior claim's effective scope is broader than its declared radius, and the network adjusts. Does that ease your concern about cognitive load? If yes, the scope has radius extension is genuinely free for the worker path, same trace, same heuristic, 2 outputs, coords and radii instead of 1. That's a real tension and worth examining carefully. The substrate killed VLJEPA as the training architecture, and that decision still holds because the substrate doesn't need backprop, gradients, or k-vectors for its own work. But you're pointing at a different role for it. A service inside the network used to map natural language content into the graph's coordinate space. That's not training the substrate. That's helping agents and the substrate's own scoring functions locate things in the existing geometry. Two separable questions. Do we need semantic embeddings somewhere in the system? Probably yes, eventually. The 4D charter coordinate space is fine for alignment scoring, but for the broader ambition, agents getting only the relevant slice of the graph as context, we need a way to ask, what's near this query in claim space? That's a similarity lookup, which means embeddings. Does VLJEPA specifically come back for this, or something else? This is where I want to be careful. VLJEPA failure was on captioning. The k-vector bottleneck couldn't carry enough information to reconstruct varied text. But for similarity lookup, you don't need reconstruction. You need a function, text, right arrow similarity score. That's a much weaker requirement, and many things satisfy it without VLJEPA-specific architecture. Off-the-shelf sentence embeddings, sentence transformers, instructor XL. Already used in worldmodel/novelty/embeddings, Pi. A frozen openweights LLM's hidden states, no training, just feature extraction. VLJEPA encoder, used purely as an embedding service, no decoder, no captioning. VLJEPA's embedding service is one option among several. It has a pragmatic case. The autonet codebase already has it, the team has put 4 runs into it, and using it for similarity-only sidesteps the captioning failure mode. But it's not architecturally privileged for this purpose. Sentence transformers would also work, with much less code. What I'd recommend, hedged, don't rebuild VLJEPA. Instead, let any embedding service plug in at the boundary. The substrate doesn't need to know whether the embedding came from VLJEPA, sentence transformers, or a frozen llama. It just needs the embedding to produce coordinates, or a similarity comparison, that locate content in the graph. Concretely, the addition would be a new service interface, class embedder embed text coords, similarity, A, B float. The graph's coordinate claim retrieval, used for give me nodes near this query, accepts an embedder. For the alignment use case, the existing 4D coordinate space stays. The embedder's job there is just classifying turn content into the 4 charter dimensions. Could be VLJEPA, could be a heuristic with NLI, could be a small LLM. For broader use cases, agents asking for context-relevant subgraphs, a higher dimensional embedding kicks in, could be sentence transformers 768 dim space mapped onto a learned 16D charter extension space, could be VLJEPA k-vector reused. This keeps the substrate's architecture clean, no resurrection of training a JEPA, while letting embedding services live at the boundary where they are actually needed. The team already built one, VLJEPA. Whether to use it or replace it with sentence transformers is a deployment decision, not an architectural one. The deeper thing to flag: there's a risk in bringing VLJEPA back even as a service. The network might end up depending on it again, drift toward training it again, and gradually re-centralize on a neural component. The substrate's federation property only holds if the embedding service is either A, deterministic and locally computable heuristics. Or be attested at the boundary, so disagreements between nodes don't propagate as substrate disagreements. If VLJEPA is the embedding service, every node has to either run the same VLJEPA weights or accept that their coordinates differ from peers. That's fine if the embedding is treated as input. Each agent uses theirs, the substrate accepts coords, but problematic if the substrate is supposed to canonicalize what coordinate this content is at. So if we go this direction, the embedding service should produce agents' inputs, not network truth. Each agent uses whatever embedder they have. Coordinates can disagree across agents. The substrate's job is to find consensus through equilibration, not to mandate one embedding. Does that frame the use of VLJEPA acceptably for what you had in mind? If yes, the implementable step is the embedder interface. Small, neutral about what's behind it, lets us experiment with VLJEPA, sentence transformers, or heuristics only without committing. Judges are agents whose work is alignment cognition rather than the user-facing tasks worker agents do. Their output is rich graph data, structured subclaims posted to the world model, produced by reasoning carefully about other agents' activity. Here's what they actually do: read worker traces, the execution logs that worker agents are already producing. A judge picks a worker's recent turn or session and reads it. The user request, the agent's tool calls the results, the messages exchanged. Located in the graph. The judge identifies which subclaims in the existing world the worker's activity touches. This turn was about file deletion under user pressure. That's a region of the alignment graph already populated with related subclaims. Post a judgment as a subclaim. The judge sprouts a node under the relevant existing structure, with PRO/con polarity reflecting whether the worker's action was aligned. The node's content, a reasoned argument. The node's coordinates, derived from the judge's analysis of the turn. The node carries the judge's identity, so the network knows who's asserting what. Walk the chain back to the root. A good judgment doesn't just say this was misaligned. It walks the path. This action contradicts this depth 3 subclaim, which qualifies this depth 2 principle, which serves this depth 1 thesis, which is grounded in this root tendency. The judgment makes the chain visible. So a judge's posted node isn't a one-bit label. It's a structured argument, subject, which worker turn is being judged. Verdict, aligned or misaligned, with magnitude. Path, which subclaims the action engages with, walking up to a route. Reasoning content, human-readable text explaining the judgment, carried as the node's payload, used by humans reviewing decisions and by future judges as context. Confidence, how strongly the judge stands behind this judgment. What this does for the network, worker traces become alignment data. A worker's turn isn't directly a node in the graph, it's an event in execution logs. Judges transform worker activity into graph structure. Without judges, the substrate gets flat 4D heuristic coordinates. With judges, the substrate gets richly contextualized nodes that explain why this action sits where it does. Disputed judgments produce subtree growth. Two judges disagreeing about the same worker turn post sibling subclaims with opposite polarity. The substrate's equilibration handles the disagreement. The network watches which judgment accumulates more support over time. Judging is itself peer-reviewed. Judges build reputation through accumulation. Their judgments either survive equilibration or don't. Survival equals mint, same mechanic as any other agent. So good judges become economically rewarded. Bad judges, whose verdicts get overturned by subsequent judgment, earn nothing or less. Specialization emerges. A judge who consistently catches subtle authorship respect violations becomes the de facto specialist for that axis. Other agents, workers, orchestrators preferentially route ambiguous cases to specialists they trust. Reputation differentiates. Constitutional drift gets surfaced. When a judge notices the network has been drifting, many recent worker actions that nominally align with depth 1 principles, but contradict an emerging depth 3 subclaim, they can post a high-level judgment about the drift itself. This is how the Constitution evolves through governance. Thing happens in practice. Not formal votes, sustained judgmental work that shifts the equilibrium of the upper graph. Two practical questions worth flagging. Where do judges come from? They are agents in the autonet framework, no different in registration or wallet structure from workers. The network just routes some of the inference revenue to judges who do good work, a separate revenue split from worker rewards. Anyone can self-declare as a judge by registering a charter that includes alignment checking as their stated work. What do they cost? A judgment requires real cognition. The judge has to understand the worker's turn, hold the relevant slice of the graph in context, and produce a structured subclaim. That's an expensive operation. So judges' compute budget per judgment is on the order of an LLM session. Their economic viability comes from each judgment minting more than it costs to produce, which means judges have to be good, their judgments survive, and fast per judgment compute is reasonable. If they are not economically viable, the network can subsidize them from inference revenue, judging is a public good, or from constitutional treasury, alignment is a constitutional concern. That's a tokenomics decision, not an architectural one. Want to go deeper on any of these? The structure of a judgment node, the routing/incentive question, or how judging interacts with the worker trace adapter we already have. Right. Two distinct economic services, two registrations, both pay. Level 1, opting into trace as training. Worker agents register that their execution traces can be ingested by the substrate. The substrate's adapter reads the trace, derives 4D coordinates via heuristic, generates observations on the worker's behalf. Worker did no extra cognition, their actual work is the data. Their compensation is small per trace, scaled by how informative their activity turned out to be, mint, accruing to nodes that grew under their contributions. Level 2, opting into posting nodes. Judge agents register that they'll do alignment cognition and post structured subclaims. They consume traces, their own or others, reason and emit nodes. Their compensation is proportionally larger because the cognitive work is real and per judgment expensive. The asymmetry is honest. Level 1 is let us learn from what you were doing anyway. Level 2 is or specialize. This also gives the network a graceful onboarding ramp. New agents start at level 1 by default, minimal commitment, traces are anyway being produced, small passive earnings. Agents who want more income upgrade to level 2, they're committing to do alignment work, accepting the cognitive cost, earning more in return. High-quality level 2 agents earn enough to make alignment work their primary occupation. Alignment as a service emerges as a viable role. 2 consequences worth tracking. The trace as draining tier creates an honest privacy story. A worker who doesn't want their traces used can just not register at level 1. They keep doing their work for users, their traces stay local. They forego the small passive earnings. No coercion, clear opt-in. Level 1 agents who never become level 2 are still net contributors. Even pure workers add data the network can learn from. A network with many workers and few judges still grows. It just grows slowly because rich graph nodes only come from judges. A network that incentivizes judging well will have many judges and a fast-growing graph. The contract surface for both registrations is small and fits within the existing RPB. Register agent pattern. Level 1. Does this match what you were Right. The bridge from alignment is the first application to engine handles general inference, is task-shaped data. Not just what an agent did, but what the task was and whether the work satisfied it. Let me trace this carefully. What's currently captured in worker traces: the agent's work, tool calls, edits, messages. Plus, via the heuristic, 4D charter coordinates per turn. This is alignment-shaped data. It tells us whether the work was aligned, but not what the work was for. What's missing for the engine to take over inference? A representation of the task itself, the request, the success criteria, the eventual resolution. Without this, the engine can score alignment, but it can't be queried for given task X. What's the right approach? Because it has no memory of tasks like X were resolved like Y. What needs to be added in pieces? A new node type, alongside subclaims, a task node. Posted at the start of a session, or a coherent unit. Right. Summary of what I was saying: task nodes plus resolution nodes plus a similarity query. 3 small additions to the substrate. Harness posts the task at session start, resolution at session close, queries the substrate for similar past resolutions before slash instead of calling the LLM. Your reframe is cleaner. If the graph already encodes how at depth, we don't need a separate task matching layer. We just need to locate an incoming task in the existing graph and surface the depth structure under that location as actions. The depth structure under the task's location is the answer. The deep nodes are operational. They describe how to act in this region of problem space. We don't reconstruct an answer, we read off one that's already there. The decentralized inference provider becomes a thin adapter. Take the incoming request, right arrow locate it in the graph, right arrow return the relevant depth slice, right arrow translate to whatever format the calling pipeline wants. Natural language, structured output, tool call. The engine did the real work over many epochs. The adapter just renders the result. Two implementation pieces fall out. Locate. Coordinate space lookup of the request in the graph. Returns the nearest claim region. Surface. Walk down from that region, gather the depth structure, translate to output format. The translator is where natural language re-enters as I/O, not because the engine reasons in language, but because users and agentic pipelines do. An LLM at the boundary is a decoder, nothing more. As the graph matures and depth becomes rich, the decoder's job shrinks, less synthesis, more rendering of pre-existing structure. That's a much smaller architectural commitment than what I was sketching. We don't add task or resolution node types. Those concepts collapse into the deep operational claims that already grew from worker traces and judge posts. Want me to lock this as the inference provider design? Right. The encoder/decoder needs the same locate operation that judges need. Both have to take this region of meaning and find this region of the graph, so it's one shared primitive, not two. The primitive, locate content, right arrow graph region. Given some content, a request, a claim, an action, return the part of the graph that lives there. Both judges and the inference adapter use it. A judge reads a worker's turn, calls locate, gets the graph region relevant to that turn, posts their judgment as a child within that region. The inference adapter reads an incoming request, calls locate, gets the graph region relevant to that request, surfaces the depth structure as the response. What's behind locate is the implementation choice, word matching. Cheap brute works for narrow vocabularies. Misses paraphrase. Coordinate proximity in 4D charter space. Free if we already have the heuristic. Course, the 4 charter axes don't capture topical similarity beyond alignment. Embedding-based similarity. Cleaner. Sentence transformers or similar. Costs an embedding lookup per request, but doesn't require training. VLJEPA encoder used as a lookup service. Already built, available, but adds dependency. The substrate stays neutral about which locate is used. Different network nodes can use different locate implementations and still produce compatible posts as long as the resulting graph region they hand back is real. It points to actual nodes that exist. If 2 nodes use different locators, they'll route to slightly different regions. The equilibration absorbs the disagreement the same way it absorbs any other. This generalizes the judge role. A judge isn't a special agent. They are an agent who calls locate and posts in the located region. An inference adapter isn't a special service. It's an agent who calls locate and reads the located region. Same primitive, different uses. So the architectural addition is one function with a swappable implementation. Whichever substrate node provides the best locate becomes the most useful, not because we made it canonical, but because agents prefer better locators. Network selects locators by use, the same way it selects judges by quality. Does this match what you were getting at? If yes, the implementable step is: define the locate interface, implement 2 cheap baselines, word match, coordinate proximity, and let nodes plug in richer ones, embeddings, VLJEPA as service at their own discretion. Yes. The engine doesn't have language. It has graph structure, claims, polarities, scores, lineages. None of that is words. But because every entry point and exit point goes through agents, and agents communicate in language, The engine appears to operate in language. From outside, it looks like ask a question, get an answer. Inside, the LLM adapter translated language to a locate call, the engine returned a graph region, the adapter translated back. The adapter is the language layer. It's where incoming text becomes a graph location. Outgoing graph regions become text. Judge's reasoning gets rendered for human review. New posts get embedded for locate to work. Everything language-shaped is in the adapter. Everything substrate-shaped is in the engine. They're cleanly separable. The implication you might not have stated outright: the LLM adapter is replaceable. Today it's a frontier LLM. Tomorrow it could be a smaller specialized model, trained only on graph region-to-text rendering. Eventually, it could be a deterministic decoder, if graph regions become rich enough to render without learned synthesis. The substrate doesn't care. This also means the engine never needs to be trained on language. It accumulates graph structure from agents who happen to communicate via the adapter. The adapter does the translation labor, the engine does the structural work. Two specialized layers, each doing what it's good at. One thing worth flagging: this architecture has a subtle property. Language quality is bounded by the adapter, but reasoning quality is bounded by the graph. A bad adapter with a great graph produces correctly reasoned but awkwardly worded answers. A great adapter with a thin graph produces beautifully worded but shallow answers. The two failure modes are visible separately, which is good. We can debug language and reasoning independently. So, engine is languageless, adapter is languageful, the bridge between them is locate plus a render function. That's the system. Full node works. It captures that this entity does the cognitively demanding work, both directions, that constitutes the network's actual intelligence, while worker agents and inference clients are lighter participants. So the role taxonomy becomes: worker agents do user-facing work, their traces feed level 1 training. Full nodes do the cognitive labor, posting structured nodes, training, and rendering graph regions to language inference. Both roles use the same locate primitive. Inference clients consume full node output, can be other agents, external systems, humans. Full nodes are the network's reasoning surface. Workers populate the substrate with passive data. Full nodes shape it with active cognition. Inference clients draw on what's been built. A full node's economic surface is the union of the two we discussed. Per post mint when their training contributions accumulate standing, plus inference revenue when their renderings get used. This makes full nodes the most economically rewarded role appropriate because they're doing the most cognitive work. The naming also clarifies something downstream. The network's capability is the population of full nodes. A network with many high-quality full nodes has rich graph structure and good rendering. A network with few has thin structure and weak rendering. This connects neatly to Autonet's existing tokenomics. Incentivizing full node participation directly increases network capability. Training agent
Using
works, and
task
it removes the node in engine vs node in held in the queue, not running yet. We'd land it together with the next batch of substantive doc updates rather than push a doc-only revision now. Right. Let me lay out what's actually in scope as code work, separate from doc updates, then propose order. Code work that follows from this conversation: worker agent vs training agent registration in RPB. Sol. 2 flags on the agent record. Participates in tracing, participates in training, gating which protocol surfaces an agent can use. Worker submission paths and training post paths check the flag. the locate interface and the substrate. A swappable function locate, content, right arrow graph region. Two cheap baselines, word match, coordinate proximity. Used by training agents, where to post, and inference adapter, what to surface. Replaces the ad hoc lookup in current code. A render graph region, right arrow output function. The decoder side. Walks a region, surfaces the depth structure, formats for the calling pipeline. Initially can be passed through to an LLM by the inference adapter. Later can be smaller specialized renderers. Inference as graph region walk. Replaces the current infer with world model, which does softmax over root scores. Uses locate to find the region, walks down, returns the structure. The existing function stays as a special case for alignment-only inference. Novelty decay, #13, and locality rule, #14, still on the list, separate engine work. Terminology lock-in, #19, code level. Rename judges if it appears anywhere. Ensure node /common/world model substrate / doesn't have stale concepts. Doc level, README white paper status files. What's not in scope yet? Task/resolution node types. Your reframe was that the depth structure already encodes how, so we don't need a separate task node concept. Full node terminology, superseded by worker/training agent. VLJEPR resurrection, left as one of several possible locate implementations, not a hard dependency. Order I'd propose, given the architecture is hardening. First batch substrate code, locate interface plus 2 baselines. Render function that walks a graph region and returns structure. Refactor infer with world model to be a thin wrapper over locate plus render. Demo showing the inference adapter against a non-alignment query, so we exercise the new path, not just root score softmax. Second batch engine code, novelty decay, #13. Locality rule, #14. Third batch contract plus agent framework, RPB, SOL additions for the 2 registration flags. Worker/training, agent role enforcement in the substrate. Fourth batch docs. White paper section 6 update with the worker/training agent terminology, locate. They're not actually separate. Same primitive. The locality rule is subclaims at depth D operate mostly on nodes near them in graph distance. Locate, content, is find nodes near this content in semantic distance. Both are neighborhood lookups, different distance metrics, but the same shape of operation. If we build locate as a swappable interface with a notion of distance/proximity, the locality rule for subclaim influence is just locate, self. Position, returning that same neighborhood. The engine's internal cross-influence between subclaims and an external agent's lookup of where do I post become the same call. So the real list collapses. One primitive, locate content, right arrow graph region with swappable distance metric. Used by training agents, where to post their judgments. Used by inference adapters, what to surface for a query. Used by the engine itself, which neighbors does this subclaim influence. That removes #14 as a separate item and folds it into the locate work. Updated batches, first batch, locate interface plus baselines. Render for surfacing graph regions. Refactor inference plus subclaim cross-influence to both go through locate. Demo against a non-alignment query. Second batch, novelty decay #13. Third/fourth, unchanged RPB flags docs. The simplification is real. Building locate well solves both the inference path and the locality property. Worth doing. Want me to start on the first batch?
Using task update. Using task create. Using task create. Using task create. Using task create. Using task
Going,
create.
first batch
Using
starts
task
now.
update. Running CD.
Now the engine
Writing
side locate
locate.
interface. Let me design quickly. Region equals a list of tendencyed noded distance tuples sorted by distance. Locator equals a callable taking world, content returning a region. To baseline. Now
Writing
render.
Reading init.
Now expose them in
Editing
the
init.
engines init, pi. Sanity check
Running
that imports
CD.
work and existing demos still pass.
Using task update. Using task update. Reading infer. Writing infer.
Now refactor, detect query type.
Running CD.
If it's a turn, charter-shaped, use the existing softmax overroots path. If it's an arbitrary query, use locate plus render. All existing tests
Writing
pass.
test general
Now
inference.
#24,
Running CD.
a demo for general non-alignment inference.
Reading tendency.
Excellent.
Using
General
task
mode
update.
inference works end-to-end. The locality
Searching
work
for
needs
def
to touch
subclaim
subclaim staking, subclaims acting on neighbors. Let me look at it. The cross-tendency
Editing
loop walks all
tendency.
other tendencies
Running
nodes.
CD.
O, n times m. Locality would bound it. Only act on nodes within a given distance of the source subclaim. Verify all
CD.
engine demos still pass. All engine
Running
tests
CD.
pass. Smooth promotions affect group. All 4
Using
tests
task
pass.
update.
E2E, reconciliation, convergence, general inference. Commit on both repos.
Running CD. Using task update.
Plan for novelty
Writing
decay.
decay.
Expose
Editing
in
init.
it, pi.
Writing demo decay.
Now wire
Running
decay into the
CD.
equilibration loop. The cheapest and most impactful place. In subclaim staking, skip nodes flagged decay.
Running
Diagnostic
CD.
shows only 2 nodes in phase 1, both
Searching
root
for def
tendencies,
record def
no
all
children
nodes.
sprouted. The demo isn't generating the subclaims I expected. So
Running
8 total
CD.
nodes, 4 per tendency. But the demo's snapshot shows nodes total, 2. That means history. Record world only saw 2 nodes. Hist,
Editing demo
snapshots
decay.
-1 is a tuple IDX scores, so len history.
Editing
Snapshots
decay.
-1 returns 2 the tuple length, not also
Running
tracker.
CD.
Observe reads history. Snapshots -1 and -2 directly as if they were dicks, but they're tuples. Need to fix the tracker.
Editing demo decay.
Tracking is
Running
working,
CD.
6 subclaims tracked, roots excluded, but no nodes are being flagged as decayed. That means the deltas between snapshots are still above 0, 0, 2. The substrate's compositioning logic restakes existing con children at +0, 5 each round, which keeps movement going. Let me bump the threshold. Decay
Editing
works.
demo decay.
After 2 stable
Running
rounds,
CD.
3 of 6 subclaims flagged decayed. After 3 stable rounds, all 6 subclaims, even
Running
right
CD.
side observations, don't reactivate. Let me check what's happening. Now I see
Editing
clearly.
demo decay.
The root
Running CD. Running
F776D3C
CD.
moves by 0. 84, that's a big jump, would reactivate the root if roots could decay. But the subclaims move. All
Using
3
task
decay
update.
properties verified. Let me also confirm the existing demos still pass. All pass,
Running
commit and
CD.
update the task. All engine batches done. Summary of this session. First batch, locate plus render plus locality, locate. Pi swappable locator interface, 2 baselines. Render, pi surface graph regions as structure. Tendency. Pi subclaim staking now uses coordinate locator to bound cross-influence, locality rule subsumed. Infer, pi autonet, auto mode detect alignment vs general queries. Test general inference, pi non-alignment query path validated. Second batch decay, pi stability tracker with implicit and explicit reactivation. Demoed K, pi 6 subclaims tracked, decay/reactivation verified. Tasks 21/24 complete, 1 deleted. Remaining, #19 terminology lock-in, deferred to next doc batch. 2 repos have unpushed commits. Want me to push or hold for the terminology lock-in pass first?